Ladies and gentlemen, thank you for joining today's session. Welcome to our webinar, which is focused on Flowmon and F5 cooperation. And you can explore how we protect ISPs against DDoS attacks. First of all, let me introduce my honored guest, which is Bernd Kunze, Senior Solutions Architect from F5 Networks. Hello, Bernd, how are you?
Hello, Lubos, thank you, and good afternoon, everybody.
Can you introduce yourself briefly? What's your responsibilities?
Yes, of course. My name is Bernd Kunze, as you said, and I am responsible at F5 for service provider security solutions from F5, which of course includes the DDoS mitigation, the solution that we have built together, but also some other security products focusing on firewalling, on layer 7 security, and so on. I'm in the industry for 20 years now, doing service provider security at various companies. And I had, of course, a chance to witness how the security space within the service providers has been growing over the past 2 to 3 years as well.
Okay, thank you very much for your introduction. My name is Lubos Monter. I'm product manager of Omo Networks. And I'm very glad that I have you here as a guest, because I have to add that you was our technical point of contact during the integrations, and you have very deep insight into our joint solution. So I'm sure you can share with us a lot of interesting information. So very happy that you are here today with me. At the beginning, I would like to share the agenda of the webinar session today. In the very beginning, I will introduce Omo Networks. Then I will introduce Flowmon DDoS Defender product and some DDoS detection and DDoS protection strategies. We will discuss it with Bernd. Then we will show you our joint solution, and at the second part of the webinar session, we will show you our live demonstration from Flowmon DDoS Lab. So you will see how our joint solution works in reality, and then at the end of the session, we will discuss your questions, we will discuss our joint solution benefits, and we will talk with you regarding deployment scenarios and various questions. So let's take a look at the Flowmon Networks introduction. We are a company based in Czech Republic, European Union. We have more than 700 customers worldwide. We were the first vendor worldwide with 100G probes offering, and we are really technology driven. We have very strong R&D background. We cooperate with academia. And on the right side, you can see some recognizable logos from our customers. So I'm sure I do not have to introduce these customers, because they are known worldwide. From the technology landscape perspective, we are recognized by Gartner. We are settled in Gartner's Magic Quadrant for network performance monitoring and diagnostics, and we are one of the fastest growing technology companies in Europe, and we are very glad to partner with premium technology vendors such as F5 is. So we can do very interesting stuff with our technology partners, and today we would like to share some interesting outputs of our cooperation. So just to be clear how Flowmon works, what we do with data, and just to have an introduction how we can cooperate with F5. This is the architecture of Flowmon. the central appliance is Flowmon collector in form of hardware or virtual appliance. The Flowmon collector collects flow data from router switches, firewalls, and other appliances with flow export capability, or from dedicated Flowmon probes. All flow data is collected into the Flowmon collector, and over the collector we have software installed for various use cases, from network behavior analysis for security use case, network visibility and features for network performance monitoring and diagnostics. Then we also provide network-based application performance monitoring, which uses Flowmon probes and measures real user experience. Then also network traffic recording is available in cooperation with Flowmon probes. And the last one and most interesting for us today is DDoS detection and mitigation. For this case, the Flowmon DDoS Defender module is installed over the collector, so we need only two components: Flowmon collector, which is the central appliance. You can collect the flow data from existing infrastructure, from router switches, and on the collector is installed the module Flowmon DDoS Defender, which performs the DDoS detection. So Flow Expert Flowmon probes can add to NetFlow records layer 7 information, so you can gain even deeper visibility as you have from standard NetFlow, flow collections over the collector, and then software modules. So this is how Flowmon works, and what is today's topic is DDoS detection and orchestration, because we all need to protect businesses and customers against DDoS attacks, as they are widely spread, and they are very cheap now and very effective. And we both with F5 have created very flexible solution, which is very efficient for DDoS detection. First of all, let's take a look on protection strategies. The known strategy, which is used often in enterprise environment, is inline protection or DDoS attacks. There, of course, on the line is settled the inline appliance, and it detects and also mitigates the attacks. Bernd, this is the domain of F5. Can you please comment on this inline strategy?
Yes, of course. If you look at an inline mitigation scenario, you are typically finding that more towards the core and the data center of the network, because you're having some very, let's say, dedicated services like your service, your EPC, some links that you want to protect the application behind against attacks. Usually we deployed this historically in the enterprise space, but also some service providers are using inline mitigation for specific control and specific mitigation for specific areas of the network. You're coming in your next slides, of course, towards the out-of-path model, and I will speak about the main differences in that slide then. But experience has shown that the enterprise protection strategy has certain limits in scaling when it comes down to service provider network designs.
Yeah, and as you said, for these cases is used another strategy referred as out-of-path mitigation, which fits large enterprises with multiple uplinks, and of course service providers and data centers, because their inline protection is has some limitations, because they typically have multiple lines, and each of it should be protected. But the combination, we both created Omo Networks with F5 Networks solution, which is really efficient, that you can combine the inline protection and very effective detection from the flow data, and then using redirection of the traffic. So any comments from you, Bernd, of where do you see the most important benefits of this out-of-path approach, not only in the limitation regarding the number of uplinks, but any other benefits?
Right. So if you compare this towards the inline model, of course, technically you can provision a dedicated inline protection device on every service provider link. So technically that's not a problem. We do have chassis which go well beyond one terabit of throughput. So nothing is holding us back except for that this solution would be extremely costly in terms of CapEx and OpEx, of course. So this leads me to the first point, where you have a shared mitigation center out of path that you deploy at a central or at multiple central locations in your network even. And depending on where the attack is happening, you can actually bring this mitigation center virtually in line by manipulating the BGP route table. So you inject a route diversion into the BGP protocol, which tells the system that specific traffic to a specific destination or from a source goes through a new path where this mitigation is happening. So the benefit is obvious. You can have one or two, depending on the size of your network, large mitigation center which are capable of mitigating huge attacks coming into the network. So you could think of a Mirai attack that we've seen by the end of past year, which has been massive in terms of throughput, in terms of packets being generated. Mitigating that inline seems to be not a favorable choice, simply because you would need to over-provision hardware in the network on each and every link. The chance of having those mitigation centers at central locations also means for service providers you can position them very close to your peering links. So you don't need to allow those attack packets to go deeper into the network. If you provision the mitigation centers wisely, then the majority of your infrastructure will not see the effect of an attack. So that, in a nutshell, is for me the benefit that you see for service providers with that deployment model.
Okay, thank you, Bernd, for your comments. And now I will introduce how we do the detection. So it is obvious that the detection part is the part of Flowmon, and the mitigation part is part of F5. So first of all, let's take a look how we do the detection. So detection is done over protected segments, which are defined by network subnets. It's really easy to set the protected segment and to set what should be happening with the attack detected on this segment. So the multi-tenancy is ensured, and for each of this segment is set of baselines learned for monitored traffic and used for the attack detection. And which is really good is that this is not only baseline for the detection, but thanks to our integration with F5 networks, we can share the baseline, we can share the thresholds, and once the attack is detected, we can push the information to F5 device, and it uses it for the subsequent mitigation, which spares time. It does not need to create own baselines and own measurements, and immediately can perform the mitigation. Some details about the detection techniques which are used in Flowmon DDoS Defender. We use minimal threshold, we use adaptive and manual thresholds. Then for adaptive thresholds, which is fully automated approach, how to set the baseline without need of manual inputs. You can use which traffic is interesting for you, and you can baseline only ICMP or UDP or TCP or some specific TCP flags. And you have also tools for false positives tune up in the system. Then, if the attack is detected, you have the reporting, so you know the start and time, who was the target, what was the type and status of the attack, and other information. But all of this I will show you later in the video recording from our lab. So you will see directly in graphical user interface of Flowmon DDoS Defender how this works. In general, we have few options or several options for how to respond to attack. The most basic is alert, of course, email, syslog, SNMP trap. We can reroute or we can do the routing diversion using standard mechanisms as PBR, BGP, BGP flowsback, or the most basic, which is RTBH. We can also do user-defined scripting. So once the attack is detected, you can run a script, and which is most important today for us because of cooperation with F5, we can do the automatic mitigation using F5 scrubbing or F5 mitigation appliance, which is natively supported in Flowmon graphical user interface, and it's very easy to set it and to work with this. One interesting option is BGP flowsback support. So Flowmon DDoS Defender creates the dynamic signature of the attack and provides this signature to routers with BGP flowsback capability with the command what to do with such a traffic which is in compliance with the attack signature. And the flowsback rules are based on the destination source prefix, IP protocol, destination port, and ICMP type and code. And this is really good for integration with other systems. You can create a multi-layered or hybrid solution. Some traffic should be rerouted scrubbing center, some other should be rerouted in another way. You can also use the BGP flowsback feature for mitigating some kind of traffic, because you can drop some packet or you can do rate limit. Bernd, where do you see the power of BGP flowsback?
So, as we have seen, it is quite difficult to control certain types of attacks, even with the most sophisticated tools that you can bring into the network. So the goal is, specifically in service provider space, to actually drop the attacks much, much closer towards the source. So if you would say that, for instance, an attack coming out of China, just to pick an arbitrary country, it can be worthwhile to have relationship with other service providers in place where I see an attack coming from China. I can signal to my upstream service provider and say, specific traffic matching those flowsback rules, please drop them for me, don't even let them come down to me. So this allows for a very cooperative model between service providers, which then can use tools like RTBH for black hole routing this specific type of traffic. The goal for us is actually to increase the good of the network. So instead of just blindly shaping all traffic, our combined solution wants to be more sophisticated and really focus on the bad traffic, trying to isolate the bad traffic out of the attack stream and drop this or mitigate this much closer to the source than up to now.
Okay, thank you for your comment. Yeah, and now we are going more deeply into Flowmon and F5 cooperation. For now, we mentioned some general strategies, how to do DDoS protection. We mentioned Flowmon DDoS Defender capabilities and how to leverage them with F5 to do the real protection, including mitigation. Flowmon have partnered with F5, and we have technology alliance, which means that we have native integration. We have created supporting documents, including landing page, white paper. You have the white paper also as a handout today on today's webinar session. So just click on handouts and you can download the white paper. And there is also implementation guide. So if you would like to test or do POC or to deploy the solution, you have all necessary documentation for this prepared. And we also do together with F5 some PR and marketing activities to spread information and to show where the benefits are and how we can together help enterprises and service providers to protect against DDoS attacks. Regarding target customers, as we mentioned with Bernd, of course, service providers and data centers, it's always better to deal with DDoS attacks on the service providers level, but some really large enterprises with multiple uplinks and vast infrastructure is also our target customers, and we can recognize two use cases. The first is the infrastructure, because our customers need to keep lines clean from volumetric DDoS attacks, and also they need NPMD toolset for troubleshooting forensics and for dealing with operational problems. And the second is security use case. So Bernd, could you comment on this?
Yes, as you said, there are mainly two use cases. The infrastructure use case explained very well. On the security side, of course, you have the concern that not only the link may be congested, but you also want to prevent the application being affected by DOS attacks. So this could be a layer 7 application, it could be in your EPC, it could be within the data center. You want, of course, have to have an insight, not only that your link has been congested, you want to understand what has been under attack, who has originated this attack, who was the orchestrator for that, what was the type of attack coming in. So beyond just the protection mechanism, we also want to give more insight and more visibility to what happened in the network. And this is extremely important, as maybe during this volumetric attack on one side of the network, another highly sophisticated low-level attack is happening on another portion of the network. So bringing all this information together, giving you the visibility, is key to do not only the analysis, but also to understand why a specific network behavior has happened at a given time. So while we come from the infrastructure side initially with DOS defense, looking at the market, the mitigation and visualization slowly moves also into the security side and also the visibility side. And this is what F5 is providing. You are, of course, benefiting from the decades long of experience F5 is having in client-to-server applications. So we have an extremely well understanding how client-server communication is happening for various applications. So we've been doing this proxy model for the past 10, 15 years. So this brings, of course, the expertise also into the security space.
Okay, thank you. So let's move to the slide describing our integration. We in Flowmon DDoS Defender supports F5 Big IP or Viprium platform, and it's very easy to add F5 appliance as a scrubbing center, which can be then be chosen and protected segment for the attack mitigation. And having the integration, we also have fully automated mitigation control. So the user is always informed how the mitigation is going on. Once the mitigation is started, there is very detailed information if everything went okay or if there was some problem. So there is this really helps in troubleshooting. So what is important, and I mentioned it before that in a few slides ago, that we do in our integration also informing the F5 device what's going on during the attack. So we share the baselines, we dynamically create DOS profile and virtual server on F5 device, and once the attack is over, we also do automatic rollback, so the traffic is rerouted back, and all configuration from F5 device is automatically removed. Now let's take a look how the attack looks like, and later we will show you the real attack simulated in our DDoS lab. So we have a service provider core in the center of the picture. On the left side are both the routers and the internet, and on the right side we have some protected objects or protected segments. So how we do the detection? We collect net flow data from the routers, we learn baselines, and once the attack occurs, we immediately know that there is an attack, and we can push informations to Big IP appliance. We share the thresholds with appliance. We create DOS profile and virtual server, and we redirect the traffic to the mitigation appliance, and it performs the mitigation. Could you, Bernd, please comment on the mitigation itself, how it works?
Yes. So once we received the configuration, which is, as you said, based on our APIs, and after the BGP reroute through the mitigation center has been activated, we are receiving the traffic. Now, what we're learning from the Flowmon side is not only one specific attack. We're also seeing the thresholds for the other DOS vectors, which of course allows us in this condition to not only mitigate one single attack like a TCP SYN flood or a UDP flood, but if the traffic stream contains multiple attack patterns, we can mitigate all of them in one go. So how that happens is, once we receive the traffic, and assuming that we have a chassis-based system from F5 in the mitigation center, we are receiving the packets, absorbing them from the wire, and we're sending them through our FPGAs. So FPGAs, for those who are not that familiar with the hardware world, these are very customizable chips which can be programmed to fulfill certain tasks instead of software and hardware. So one example is DOS mitigation, doing labs, doing filtering, but also we are using this quite heavily for decryption and encryption and some other packet handling tasks. Now, in our FPGA, we're applying the DOS mitigation already in hardware. That means before we even open a session for that specific packet types. We are already filtering out the good from the bad packets and dropping the bad ones, of course. So beyond this filtering mechanism, we're also generating lots of statistics on the incoming stream. And those statistics allow us for certain attacks, so it depends, of course, if you have TCP or UDP or whatever. So in the case of TCP, for instance, we're capable of identifying the bad sources of attacks. And this is quite important because if I see, let's say, a TCP SYN flood coming from specific source or some other identifiable client attack from a specific source, economically it doesn't make sense to send this known bad traffic every time through the mitigation engine. So what we do, we can enable vector detection. With that, once a bad source IP has been identified, we can put this bad source IP on a blacklist and say, if a packet coming in from this specific source or from this specific prefix, then please drop it for the next 20 minutes. So we can shun a specific IP address or prefix for a given amount of time. Of course, besides blacklist, you can also have whitelist for some well-known things you want not to go through the mitigation engine. But again, I have to repeat this from a previous slide. Our goal is to increase the good put. So we do want to have a higher focus on the bad guys and dropping this traffic, while we want the good traffic to the mitigation center unharmed. So depending on what the role of the device is, because you can add certain other tasks in the security space to the mitigation center if wanted, we then forward the good traffic onwards to its final destination.
Thank you very much for your comments. And here is a summary of the previous slide, that Flowmon does the detection on protected segment, extracts the signature, and then creates virtual server and DOS profile on F5 device, diverts the traffic, F5 performs mitigation, and reports the end of the attack via the API if the attack is over, and then Flowmon does the rollback to the normal. So now I have prepared a video from our lab. So yesterday I spent in our Flowmon DDoS lab, and I played with our joint solution, and I created a synthetic DDoS attack to show you how the solution works. So let's take a look on the video. So how does our lab environment looks like? We have the attacker, we have the victim, we have deployed the Flowmon collector with Flowmon DDoS Defender module, and we have F5 big IP in place. So here is the attacker's console. Here is the monitoring of victims' network interface. I'm running a ping from attacker to victim, so we can see there is really connectivity between attacker and the victim. And now we can see that in DDoS Defender is no attack yet, and we can also see that there is only that ping in the Flowmon monitoring center. So I have to use the logarithmic axis to be visible that few traffic here. So let's get back the logarithmic axis, and here is our ping. But this is really boring for us, so let's launch the attack, and I'm using hping command for generating the attack, and you can immediately see in the bottom in the screen with the monitoring of a victim's interface that there is increased traffic on the interface. And now we are back in Flowmon DDoS Defender, and we have to wait few. Yeah, here is attack is detected. It typically lasts about 30 seconds, but depends on the interval what is sketched. So now we can see active DDoS attack, but let's take a look on the configuration. So as I mentioned, you have to configure protected segment, which is defined by network segment subnet. Then you can choose the action, changing the route option. Here is enabled mitigation via F5. You can choose automatic or manual. For this lab, I use manual. It's comfortable for me to show it that in manual way. Here you can see how the rules, detection rules looks like. You can set baseline learning period, manual threshold, adaptive thresholds, or you can choose which baseline should be learned for this protected segment. And of course, there is also static methods, which is simple ratio between incoming and outgoing packets. Yeah, let's take a look on the alerts. As I mentioned, we can send syslog, SNMP email, and you can also run a script. Then you can configure routers, but what is important for us is scrubbing center. So I will click on the F5 scrubbing center, where is IP address and credentials and name for the scrubbing center. Then it appears in the segment as an option to choose for mitigation this appliance. So let's go back to the attack list and let's take a look what details we have on the attack. So we can see the attack. There is some attack in the past. We can see the status and the details. Here is the signature of the attack and some top statistics of for this specific DDoS attack. And in the bottom, you have options to choose the mitigation, but also here on the list, you can choose manually mitigation. Because of the settings for this lab, I used the manual mitigation. So you can see mitigation device, which subnet should be mitigated. And now watch in the bottom left victims monitoring, and you can see as the traffic dropped, once the mitigation started, we can see that the mitigation or the redirection and all stuff went good. And now the green mark shows that the mitigation is running well. You can also do the analysis of the attack. So you can switch to Flowmon Monitoring Center and you can do deep drill down, but this is not what I would like to show you today because we do not have time for deep drill down. So let's take a look how the attack appears in big IP. So you can see that profile was automatically created, and then you can see details regarding the attack, what's going on with the attack in the system. So here you can see the list of profiles, and here is analysis and charts and statistics regarding the ongoing mitigation. Maybe I will pause the video, and Bernd, do you want to comment on the user interface and what we are looking on here? Do you want to add something?
If you look during the attack or even after the attack on the F5 web UI, you will find not only current information about ongoing attacks, but you can also go back and look at what attacks have happened in the past. And this is actually combining our the two solutions quite nicely, because we not only give the start and stop time of an attack, we can also sample packets for later for forensic use cases should you be looking into this. So of course this grid that you have here is very comprehensive. It is more acting like a dashboard. As I said, it's not only giving you historical attacks, but also giving you the information where do the attacks come from, because we just saw the screen scrolling up and down, and we have seen that there is a world map on there. So we use geo-IP information as well to visualize where the attack has been coming from. Sometimes that is very important to understand, because let's say if you are seeing a very huge attack coming from one specific country and you don't have any other choice, you could actually try and use and route traffic coming from a specific country to your network. It's not a preferable choice, but in the case of extreme attacks, it's a viable defense mechanism should you otherwise overrun your mitigation capacities, which could happen. So, but the majority of control and visualization, of course, is in the Flowmon console that Lubos has been showing you previously.
Okay, so now we are going on, and I'm stopping the attack. So we can see in the monitoring, victims monitoring, that there is no traffic, no more traffic there, and we need to wait until the Flowmon DDoS Defender gets information from F5 that there is no more attack, but I can stop it manually. So I will use the manual stop for mitigation. And again, I have the details how the stopping of mitigation went. So now I have confirmed that the stopping was okay, and we can then check also in big IP graphical user interface that I have to refresh this, and there should be removed also. Yeah, there is only that default profile, but the profile which was created regarding this attack was automatically removed. So this was the mitigation, how it worked in our Flowmon DDoS lab. And any comments from you, Bernd, on this, or can we move for the discussion?
So let's move on to the discussion. So let's see that we get some interesting questions from the audience.
Yeah, I've seen some questions there. So first of all, to please comment, Bernd, comment on integration uniqueness of our solution, how you see it is, and in the meantime, I will go through the questions, and I will prepare the questions from audience.
Okay. So let me take this part. So I think on the market, it's first that we have a very open integration between two solutions based on open APIs. So both Flowmon and F5, we've both exposed our APIs to the outside world, and basically that makes it quite easy to also integrate third-party applications. Let's out a SIEM which could inject some information from the logs into mitigation solutions. So while this is theoretical for the moment, it shows that instead of building a kind of walled garden approach, both F5 and Flowmon, we have built the solution based on open standards and open APIs. The other uniqueness is that we are going beyond just doing volumetric DOS mitigation. The market has shown, the security situation has shown that simply doing this is not enough. We need to also look at the other components of communication. So we need to answer the question how to handle SSL traffic. It's quite viable that SSL is used to actually hide attacks from the outside world. So F5 has means to actually decrypt SSL traffic before it goes into the DOS mitigation. So that is a very important step towards a future-proof solution for doing. Now we also have lots of expertise in the application space. As I said earlier, we have our own award-winning web access firewall here, which actually can also protect the applications on layer 7. So where do we want to go? We want to take the DOS mitigation market into a new sphere. We want to combine multiple mitigation tools into a very comprehensive mitigation center, and we don't want to stop just at doing the volumetric. We want to do the quality mitigation based on layer 4 to 7 on this traffic. In that sense, I think the uniqueness is that both vendors have worked together to create this solution, to also build the foundation for future additions to this solution. We can actually deploy this joint solution in various stages. So I call this a multi-tiered model. Now, of course, for service providers, that out-of-path mitigation model is the model of choice, as it is economically preferred. So you spend less CapEx and OpEx on the solution. But if you look at it from a multi-tiered model, you could look at that this out-of-path solution is shaping the traffic, is dropping, mitigating attacks, and to make it suitable for consumable, and put it into consumable chunks so that the rest of the network can absorb this. And the next step in mitigation could be that you could have a second layer, an inline layer of DOS solution sitting in front of a specific application, which is focusing on specific components. Let me give you an example. We understand from a service provider perspective that your control plane deserves very special protection. If you take DNS as an example, or SIP, we have specific SIP and DNS vectors which not only look at this traffic as a whole, but we can look at SIP messages individually and actually mitigate DOS attacks. We can look at DNS query types specifically. So that means while you might have an invite storm, we can mitigate that, but we can leave the other SIP methods unharmed. The same goes for DNS, of course. So this is something very interesting for service providers we bring to the market because it gives you granularity. It not only drops the traffic as a whole, it focuses actually on the bad traffic. As a third option, as a kind of last resort option, we have seen that in the past years that attacks can grow quite large. If you look at what Mirai was capable of doing in the excess of 600 gigabits per second, if you should see that an attack on your network is exceeding your mitigation capacity, the joint solution can also signal to a cloud-based mitigation center such as Silverline from F5 and say, okay, I have a specific prefix which is under attack. I cannot handle the attack on-prem any longer. I need to involve a cloud mitigation center and send certain traffic for cloud mitigation to that new destination. So this would give us a 3-tiered model. If you add BGP flowsback to this, you can even make this a 4th tier because it can signal to upstream routers and say, hey, don't even send attack traffic to me, drop it on your premise already. Okay, so have we got additional questions?
Yeah, we have a lot of questions. So I'm wondering if we can answer all of them now, but for sure we will follow up all of you with the answers. But let's do as much as we can. So the first question is, how long is the cycle time, detection, action, remedy, matter of seconds, minutes, etc. So yeah, the question is, what is the mean time of resolution and mean time for action? From our perspective as Flowmon, we need about 30 seconds for the detection. Then the redirection is done automatically. This is matter of seconds, and the subsequent mitigation is matter of another seconds. So do you have, Bernd, some exact numbers of how many or what time do you need to start mitigation?
So from the F5 perspective, once we receive the DOS configuration, we will receive your threshold as soon as we have this information. And as you said, it's a question of seconds just to push that configuration from the flow collector to the F5 mitigation center. As soon as we have this, we do start mitigation. And that is one of the benefits, that after redirection, we don't have to relearn the thresholds. We don't have to relearn the good from the bad traffic. We derive that knowledge from the flow collector who has done that piece of intelligence already. So if I would estimate the mean time until mitigation, it is much less than 1 minute, I would say. So I haven't seen anything longer than 45 seconds. On the other side, you don't want to start mitigation too early, right? Because diversion of traffic is, of course, in a huge network, sometimes a costly process. You want to be sure that you really have an attack before you actually redirect the traffic. Having said that, in the recent past, we have also seen that the attack duration from an attack pattern type has decreased. So we are seeing huge spikes in attack traffic, but they only take a very short amount of opinion. It is testing from the attacker's perspective how fast mitigation can react. And as I said, we are in extremely good shape here.
Yeah, okay. Another question, with F5 inline, it can both detect and mitigate the attacks. What do Flowmon add in this scenario? Yeah, of course, for the inline, real inline use case, Flowmon doesn't make sense to deploy, because what we do together with F5, we try to approach that out-of-path projects, which are typically the service providers, and here is where we can do really good job. This is not a case to replace traditional F5 inlines detection and mitigation together with Flowmon. Or any additions from you, Bernd?
Well, I would say that if you want, you can play a role in the inline game, as because depending on what mitigation device you deploy, you can sit in some place in the network and make sure that the mitigation device is not overrun by traffic. And once you exceed a certain threshold, redirect the traffic through another path or do some other actions based on the traffic, such as flowsback insertion or RTBH. While Flowmon would not have an active part in mitigation here, still it would help in ensuring that the network is being kept in a healthy stage and that the mitigation center is used up to what it has been defined for.
Yeah, and still Flowmon has another use cases, network performance monitoring and diagnostics, network behavior analysis, network-based application performance monitoring. So there is definitely space for Flowmon together with inline detection, but from pure pure DDoS use case, of course, this is not what we focus on together with F5. And this is one of the things I would like to mention, that F5 plus Flowmon together is much more than DDoS protection, because F5 does a lot of other interesting stuff and other security stuff. Flowmon does another networking and security stuff. So we both together with F5 provide much more than DDoS protection. There is another question regarding, we mentioned open APIs, and what does it mean? Yeah, there is, I mean, F5 has its own vendor-specific API, Flowmon has as well own vendor-specific. Yeah, you are right, but what as we mean open API, you can via our vendor-specific APIs connect to third-party systems. We use our APIs to cooperate together, and we are open to integrate with other third-party solutions. Yeah, another question. How do we calculate the bandwidth needed for the DDoS Defender system in a service-provided network? Yeah, this is the Flowmon DDoS Defender licensing is based on the legitimate traffic. So this is how we work. So we just need to calculate the legitimate traffic. So there is no other license limitations. How many bandwidth is possible to mitigate? Are there, Bernd, any limitations on bandwidth?
Of course, there are limitations, as always. So F5 has a very broad portfolio in terms of what we can offer in terms of mitigation appliances, virtual systems, although I would leave them outside for the moment, but also chassis-based system. Before, you can go anywhere from the very low-end systems, maybe 1 to 10 gig capacity on the networking side, up to 600, 1 or 2 terabit of traffic. So I was now about to say 600 gigabit up to 1 to 2 terabit in a blade-based chassis system. So you have a very broad choice that you can actually take. As you mentioned, the Viprion platform, for most service providers, that is the platform of choice, because you can start with a chassis which is quite inexpensive and then add blades as you go, so you don't need to reprovision, let's say, complete systems. You simply add capacity on the go to the chassis, and that is sometimes very favorable, as we know that attack volume has increased over the past. For most service providers, this is a key buying argument, that you can add capacity on the fly should you need it.
Okay, thank you very much. We are out of the time now, so thank you very much for your questions. I will answer your questions and follow-ups, so don't worry about answering your questions. Now we have to end our discussion, and thank you very much, Bernd, for joining the session. It was very interesting also for me to hear information from you, and thank you for sharing your experience and your informations. Thank you all for attending this session. The session was recorded, so you will have also the recording available, and I'm looking forward to seeing you in another webinar session with us. Thank you very much, and goodbye.
Thank you all. Bye-bye.